All right, so we're gonna try to solve secant x dx. It is one of the most, I guess, dramatic integral in Calc 2 after secant cube x, because that obviously is a bit more tricky, but it involves solving secant x dx. So there's a reason why this integral is difficult to take, and before I show you the trick to take it, I'm going to show you why it is, where the drama comes from. But first of all, I'm not joking when I say that you don't take this integral. You take this integral by never taking it, because you can take this specific integral. So you kind of, with trig, you can use trig identities and move to a different trig identity and take that integral. Actually, there was a difficulty involved with this integral initially, and the teacher of Isaac Newton was the one who solved it. He used limits to avoid this problem with what I'm going to show you in a second. Okay, so this is a secant graph, and these are secants, right? So I want you to remember something really important. Secant is a reciprocal function to cosine. What does that mean? It simply means that cosine x is 1 over secant x, and secant x is 1 over cosine x. Okay, so let's try some random angles here. Cosine of 60 degrees, or pi over 3. Okay, that equals 1 over 2. And at that point, secant of same angle is 1 over 2, which is 2. All is well with the world when we're talking about pi over 3. However, cosine pi over 2, 90 degree, that's 0. Reciprocal of that is 1 over 0. And in mathematics, all your alarms should go off at this point, because you know that. So you do panic at this point. So this function blows up at pi over 2, and it becomes undefined, right? So the way that Barrow, the teacher of Isaac Newton, was able to solve this integral was with using secant x with epsilon pi over 2 minus epsilon, when epsilon is like very close to 0. So you're a little bit on the left side. You're never hitting this spot pi over 2 exactly where this function blows up. Okay, because remember, you can't just take integrals of functions that become undefined, indefinite integrals, right? Because these are real functions. So yeah, you have to be careful. This is why you never take this integral, and there's a trick to taking this integral. So it's this fraction that you multiply it with, and then you kind of have to remember. I don't know how else you would be able to solve this integral. Okay, so at this point, I'm simply going to multiply this through. So that will be secant square x plus secant x tangent x, and all of that divided by. Okay, so looking at this derivative right now, it looks pretty awful, but in just one step, it's gonna become so much simpler. You'll be very happy. I'm obviously going to do a u sub, because u sub is what makes awful looking integrals look so much nicer. Always you want to get your denominator to be u. Usually that's the case, right? Either you want if this was under the root, that to be your u, but denominator is usually what you're trying to get to be u. And then your next challenge is, do you have derivative of u sitting in the denominator? In this case, you do. If you forgot the derivatives of these functions, so you need derivative of secant x, and I've given it to you here, and you need derivative of tangent x, and that's secant square x, okay? So if you forgot your derivatives, this is a perfect time to review them, because you're going to need them all the time in Calc 2. And derivative of tangent is secant square x. Don't forget the dx, because how else are you going to take the integral, right? You need dx or du. Okay, so this whole thing ended up, well, in a little bit of different order, but it's secant x plus secant tangent x. But it doesn't matter because there's a plus here. And remember, 5 plus 6 is same as 6 plus 5. So now I'm going to rewrite this integral as I use with my new u sub. And it already looks so much better, right? That's what u sub does. It makes a very complicated integral like this turn into something so easy that is part of your basic rules for integration. So that's simple natural log ln, right? And I'm going to go back to the original variable because the problem was in terms of x, not in terms of u. So I need to back substitute whatever I promised u would be to put that back here. Not going to forget the constant of integration. And this is your final answer. Okay, now let's take a look what we did here. Always review your little strategy for the problem. So we understood we can't solve this integral, so we solve another one. This one is the one we solved. And after a simple u sub, it was like a one-step problem after u sub. There's another way to solve this integral where instead of multiplying it by secant x plus tangent x, you multiply this by cosine x. And maybe this is simpler to remember. However, after this point, this solution is way more complicated and it's lengthier. So it's a great way to practice your skills here because you're going to need a u sub here, a u sub here, and you're going to need to apply a lot of logarithm rules. Like minus is division and plus is multiplication with logarithms. This comes out as a coefficient. Those are log rules that you would review if you practice this. But on the exam, I would definitely go with this way because look, it gets solved in one line instead of the other way takes whole page.